Everyone, I'm Kshitij, and this project is called CollisionCloud. I built the front end that users interact with, and my teammate Anuj worked on the back end and the system too. We built CollisionCloud in order to solve a very simple but effective problem. Today, when a road accident is recorded, whether it comes from a CCTV, a dash cam, or any other video source, that video often becomes the main evidence. But just watching a video does not clearly explain what really happened. People still have to watch the footage again and again, frame by frame, and guess things like speed, movement, and the exact moment of impact. This process takes a lot of time and depends heavily on who is watching the video. Multiple people can have multiple opinions about the very same video. There is no clear way to understand who is at fault. Collision Cloud solves this problem by automatically analyzing accident videos and turning raw footage into clear, easy to understand insights, helping people understand accidents faster and more accurately. Now, my teammate Anuj will take you through the working of the whole project.
Hi everyone, I am Anuj and I will walk you through how Collision Cloud actually works behind the scenes. So let's get started with the flow. We will go through the flow one by one and I will explain why everything is needed and what is the impact of it.
Now we are back on dashboard. Let's create an account. So the flow is like the backend is handling heavy computational tasks because it needs GPU and CPU for intense processing because we are using YOLO plus ByteTrack, which is YOLO is for vehicle detection and ByteTrack is for tracking multiple objects and assigning track IDs to each objects. And we are using NeonDB for database, which is a PostgreSQL, and all the file system operations are happening in the backend processing, video downloads and frame execution. Real-time processing is also happening in the backend server because it is using YOLO V8 and it requires GPU. So we'll create a new project, let's say Noida. This is the project for Noida accidents. We'll choose the new video file. Let's say we choose the accident MP4, which is a 10-second video accident. Let's wait for it to happen. It is uploading on the Cloudinary. We are using Cloudinary for uploads like video uploads, PDF generation uploads, audio uploads. We are using 11 labs for the audio generation. I will show you that in the future. It is loading currently. As you can see, this is the dashboard. Let's switch back to the docs section, which is I will walk you. We are using Fast API, and this is the endpoint for showing the routes. I will walk you through each route and explain what each route is doing. As you saw the dashboard, let me log in. So before we start video processing, we have to do a calibration. Here, calibration means homographic calibration. Basically, if the car moves 50 pixels in the video, how many meters did it actually move on the road? To do this, system needs a mapping between video coordinates and real world coordinates. For calibrations, we would create a session. Let's go and get the project ID. Let's paste the project ID that we just created, which is Project Noida. We have created a session and will provide the image X norm, image Y norm, which are the pixels on the video and the latitude and longitude on the map. For now, I will simulate this process. I'll get the session ID and I will click execute. What we are doing here is we are collaborating the video pixels and mapping it to the real world longitude and latitudes so that we know what was the speed on that road. We have got this and we have to solve this also. So this is the update pair route. We created a session and we updated the pairs and we will solve the matrix. Basically, it computes speed with collaboration and distance between vehicles. It creates a 3 by 3 computation matrix. It allows system to compute real world distance, speed, etc. We have created a collaboration and let's now start the processing of the project. This is the start processing route. Let me get the project ID, try it out and paste here. As you can see, the processing has started and it is enabled with collaborations like speed calculation is active. It will calculate the speed also. It is currently processing. I can take this run ID and check the processing status, execute. You can see the processing is completed and total frames are 602, process frame 602, detection counts 5656, and unit tracks means how many unique vehicles are there. There are 17 vehicles in the frame. Next is we'll check how many detections it got. So let's click on this, paste the project ID, execute. As you can see, this is the detections, like it has class name, confidence, center X, center Y, and speed M milli per hour, miles per hour. And you can see here also world X and world Y, which is longitude and latitude. You can see speed here also, like 150 at that moment. Now let's check the route. Let's check what is the collision data. Currently we are still on the backend server, and as you can see, these are the top collisions between track ID 1 and track ID 12, and the distance and duration frame 10 frames. Peak overlap frame was 233. Now we got the data, we got everything we need for the Kestra flow, and let's go to the Kestra flow and execute the AI summary and PDF generation, audio generation. Let's go to the Kestra. Let's click on execute flow, project ID, auth token. I need to get the auth token, so let's log in to get the auth token. Try it out. Let's execute this and get the auth token. We are using JWT for getting the for login and tokens. Let's paste the auth token and click on execute. It will check like if the project has collision data, which was processed from YOLO V8 and ByteTrack, and then it will get the collisions. It will log the collisions. So 3 collisions, get collisions. It will get the screenshot of the 2 collisions of the vehicles, and that will be used in the PDF generation. And we are using Gemini for AI analysis. It will save the AI summary to the NeonDB. If I click on AI summaries, then you will get the all the AI summaries. This is the recent one, AI reconstruction. As you can see, everything is mentioned here. It will generate a PDF. So this is the PDF. It is basically creating a container, temporary container, and it is using Python to generate PDF, and it will kill this container after the PDF is generated. As you can see, PDF is generated here. I need to go to Cloudinary, click on reports, download this report. See, this is the accident reconstruction report, and here you can see AI analysis report, executive summary, what is the summary, and detailed collision analysis, vehicle trajectories, impact dynamics, and severity assessment. Basically, it is making decisions on the data using Gemini 2.5 Flash model, and the timeline, safety recommendations, driver behavior and education, vehicle design, technology and design. It is guessing what vehicle it is in the video. Now it's generating audio. As you can see, the audio has been uploaded. Currently, it is creating 2 audios, Hindi version and English version. I'll mention this in README, so you can also listen to that. Now we can see the flow is completed. The Kestrel flow execution is completed. Everything is completed, like generating PDF, uploading to Cloudinary, and generating audio using 11 labs. It has 2 versions, English and Hindi, and you can see the workflow has been completed. Now let's go to the dashboard, and we can see here everything is in place, and you can see collision analysis like mod rate, severity, max IOU, duration 10 frames, where in 10 frames the collision happened between 2 vehicles. If I click on the video, you can see the collision happened. Now you can see the event timeline also, like approach, vehicle 1 and vehicle 12 are approaching, and then first contact happened, and peak overlap happened, and then separated. The 2 vehicles are separated. We can see the AI summary recommendations here also, like post impact trajectories, final risk positions, delta V calculations, crush analysis, justification for severity assessment. Everything is mentioned here, and the users no long have to go frame by frame and see the video and then get to the result. It makes everything easy, and using AI we get to impact on the real world problems. Thank you.